Yes, hello friends. So this is the video tutorial for today's GFG problem of the day, which is add number linked list. So in this question, you're given two linked lists. These linked lists are all are numbers, so real numbers, and you're given the head of these both of these linked lists, and we need to find the result or the sum of this. So like head is the first number is 123 because as we can see this is the linked list 123. The second number is 999 because this is in the form of a linked list. Now we need to add these values. So if we were to add them, we will get what one okay sorry 123 triple nine. So this would be 12 and 12 and 11. So we'll get 1122 and we should return 1122 in again a form of linked list. So this would be 1 1 2 2, right? So yeah, as we can see, this the output should be in the form of a linked list and 1122. Similarly, we can see for this test case. Now the question also says that the uh, yeah, the linked list that you are given to us is not sanitized. So not sanitized basically meaning that there could be zeros at the starting of the linked list, but the final returned linked list should not have any zeros at the start. So that we can handle explicitly in a code. But yeah, how do you solve this? So let's say if we were to deal with this test case. So how are additions done? Additions are done like here we need to add 0063 and 07, right? So if I give you how do you add these numbers, you will say, okay, I will start from the back and I will add this 3 plus 7 0 okay 0, and I will get a carry and I will add a carry to it. So 6 plus 1 7, this zeros will just add it, and then I will just remove these starting zeros, right? So this is how I will get my answer 70. But in linked list the problem is that we are dealing with front and then have the back element. So in reality, in additions, we need to deal with 3 and 7 first, then we need to deal with 6. But in the form of linked list, we have 0 0 6 3, right? And this is 0 7. So 0 7 in this form. So if we are dealing in linked list form, the problem is that we will deal with 6 0, then only we can, because see, a linked list will have a, if any element of it will have the next element and its data, right? So I can only get to 3 7 after traversing from 6 0. So the problem is that I need to uh, uh, if I add these two first, so if I add these two 6 and then I add this 3 plus 7 0, I have a carry, so I have to move a carry. Now you can say, okay, I can maintain a previous pointer and then add it to the previous pointer if I have a carry. Okay, this will work for this test case. But let's say if this was 9, then you will add it here 9, then you will say, okay, I have my previous pointer and I will add it to my previous. So this becomes 9 plus 1 0. Then the problem again is the same, that now you need the previous of this, so you will have to keep a space of it, keep an array of all the previous pointer, which will add some space. So that is not the best way. The best way is simply just reverse both of these linked list. Let's reverse it, because see, have to deal with, we'll deal with the last element first, then we'll deal with the second last, then we'll deal with the third last, right? So rather than like maintaining all the previous, we can just reverse the array. So reverse the linked list, sorry. So if we reverse the linked list, this would become 3 9 0 0, and this would become 7 0, right? Now we can deal with this, because now the first element of the linked list is 3 7. So 3 7, let's add it 0, and I have a carry. I will move my carry here, then I will get 0 again, and I have a carry. Add my carry here, so this becomes 0 0 1 and 0. Then finally, because we reverse the linked list, we get the answer of the number also in reverse order. So we'll again reverse it. We'll get 0 1 0 0, and then again we can just remove the starting zeros, and finally we'll get the answer in the linked list form. So 1 0 0, right? So what is the algorithm we find out? We'll reverse both the linked list, reverse both, we can say numbers, where we are saying that numbers is of the form linked list. Then we'll add numbers, and then well finally, let's say this gives us an add numbers. So let's say the two linked list, one is head 1 and one is head 2, right? So first we'll add head 1 and add head 2. Now we'll add numbers into head 1. So head 1 equals to head 1 plus head 2. because we do not want to create a new linked list that will actually take space. So it is better that we just add all the values of head 2 into head 1. Then finally we'll reverse head 1 again, and finally we can return our head 1. Yeah, this makes sense. The only thing that I would suggest is, because the question does not say that which of these numbers is greater, right? So what could happen is, let's say we are dealing with this case that head 1 is 10, so this is of this form 10, and head 2 is something like 9 1 0. So what you will do is first reverse this 0 1, reverse this as 0 1 9, right? So I'm adding into head 1, right? So this would be 0, then 1 plus 1 2. Now this becomes empty, right? This becomes null. So this is a bit trickier implementation. What I would suggest is that add another step here, and we'll check if length of head 1 is greater than length of head 2. Basically that sorry, length of head 2 is greater than length of head 1. Swap head 1 and head 2. Basically this will guarantee that I'm only adding my elements into the bigger linked list. So rather than doing this, because see, additions are like x plus y is same as y plus x, right? X plus y is same as y plus x. So rather than doing 1 0 plus 9 1 0, it is easier for me to do 9 1 0 plus 1 0, because then I am guaranteed that the list I'm adding into will not finish first, the second list will finish first. So this would be an easier implementation, and I will show you in code also. So what I will do is 0 1 0 1 9 0 1, and the 0, this gets added 2, and this remains 2, and this will find, then reverse this again. I will get 9 to 0. Yeah, let me show you the code, and I will show you why this implementation becomes easier. I implement this reverse function. This reverse function will give me two values. One is the length of it, the length of the array, and also the reverse head of it. So I am assuming everyone knows how to reverse an linked list. So how you reverse an linked list, let me give you a slight inclination of how to do this. So let's say this is a linked list 0 1 2 4 3. So we'll maintain a current pointer, we'll maintain a previous pointer, because for making reverse, 0 has to point now to null, 0 has to now point to null, 1 has to point to 0, 2 has to point to 1, 4 has to point to 2, 3 has to point to 2, and this would become a new head, right? So basically we maintain two pointers. Current is the current variable, the current element of the linked list we are on. Previous is the previous element. So all we need to do is current next becomes previous. Now the only thing is that current, if you change this current next, you should also store in a variable next, let's say next t, this is current next, because see, just like when we swap two elements, how do you swap two elements? Let's say if we want to swap x and y, you have to store in some other variable, temp variable, right? In some temp variable x, and then only you can do x equals to y equals to temp, right? So this is what you are doing, because you are changing currents next. So that is why you have to store it in a some variable, other variable, and then only you can do current equals to current next. Because if you directly do current here, next equals to currents next is previous, so you will go into an infinite loop. So this is how we do swaps. So why I'm calculating length also in this, because I want to do that swap between head 1 and head 2 based on length, right? So that is why I'm calculating length here only. Otherwise you will have to do another iteration over the whole linked list to get the length. Okay. So yeah, it's pretty simple reverse implementation. I first of all store in this next, the next of the current. Then I mark my currents next as previous. I make previous equals to current, because now I'm moving ahead in the linked list. So previous would become current, and current equals to next. As I said, if you directly do current next here, so current next is previous. So you will go into an infinite. Okay, and finally we can do length plus plus, and finally we can return previous and length, because when we have iterated over the whole linked list, so 0 1 2 4 3, so current would be null, so current would be here. Okay, why is this not writing? Okay, yeah, so current would be here and previous would be the head of the linked list. Okay, But this is this pretty simple and pretty popular reverse implementation. So in our code, we'll first reverse the both of the linked list, reverse head 1, reverse head 2. I will get the RH1 is reverse head 1 and RH2 is reverse head 2. Now, as I said, if length 2 is greater than length 1, we'll swap both of them, and then we will add into head 1 and we'll add head 2 into head 1, right? So I'm swapping this. So if length 2 is bigger, RH1, reverse head 1 becomes reverse head 2, right? And vice versa. So that is why we then in that case we are adding into reverse head 2, reverse head 1. This is a bit tricky, but yeah, you can understand this code. It's pretty simple. And what we do in this add function is basically now in this add function I'm guaranteed that the length of head 1 is greater than equals to length of head 2, length of head 2. And why this is beneficial? Because we can just keep adding current 2 elements into head 2 till current 2 finishes. What I mean by this is first we'll maintain a carry variable and we'll keep going till current 1 finishes. Now add is basically how much value should we add to this current 1's data. So if there is a carry, we'll have to add carry, and if current 2 has not finished, we'll have to add the whole current 2's value. So add plus equals to current 2's data. Then in current 1's data, we'll add plus equals to add. So total add that we have to do here, and we'll mark carry as 0. Now we'll check if there is a carry. So when there would be a carry, if the current digit becomes greater than equals to 10, right? If we do some like this, like current one's data was 3 and we are adding 9 to it, so this becomes 12. If the addition becomes 12, how we are storing it, we will store 2 and make carry equals to 1, right? Pretty simple. Okay, so if current one's data becomes greater than or equals to 10, we'll mark carry as 1 and current one's data minus equals to 10, right? Which makes sense. Now this is an important check, that because if there is a carry and current one next becomes null, then we'll have to create a new element of it. So this is this case that let's say we were doing 0, 9, 2, 1. So this becomes, so this is like 90 plus 12, right? So we have reversed this, so 0, 9 and 2, 1. So I add this, so 2, and now I am adding 9 plus 1. So this becomes 0 and I have a carry. Now this current one has finished, so we have to add a new element, and in that new element we'll add carry, right? Which makes sense. Okay, so if this is the case, that current one's next is null and carry is there, so I will have to create a new element, current one's next equals to new node. I will store 0 currently into this, and I will move my current one equals to current one's next. And this is basically to if you just do this nakedly, then this can lead to segmentation faults. So that is why we're checking that if current 2 is null, if current 2 is not equals to null, then only move current 2 equals to current 2 is next. Okay. So pretty, yeah, hopefully you were able to understand this add function. And finally, we just reversed the RH1. So reverse, why we are reversing into reversing our head 1 is because, as I said, we'll add into head 1. So this is add head 2 into, let me add it here, add head 2 into head 1 to head 1, where length of head 1 is greater than length of head 2. Okay. Then we'll finally reverse head 1, and finally also the next final thing is that we have to remove any preceding zeros. So how we can do this is just remove zeros. So we'll just keep iterating over the linked list till the first element is 0. So if the first element is 0, so like the number is 0070, right? So we just need to keep iterating over the linked list till the element is 0. If like this is 0, so this cannot be the new head. This is 0, so this is again, well, I keep iterating. This is not 0, so we'll return this as the head element. If I return this as the head element, all the values after it are not preceding 0 because this is not 0. So this number is valid and does not have any preceding value. Because see, this, if I return this, the number is 070. Then if I return this, the number is 0070. If I return this, because this has the head, the number would become 70, which makes sense. So I just keep iterating over the linked list till the variable till the data is 0. If it is 0, I will move to next, and finally if it is not 0, I will just return this loop will break, and this will return current. So finally I can just return the final answer of removing 0 from answer. This works. Thank you for watching. If you were able to understand anything and you like the video, give it a like and subscribe, all of those things. Bye.